Welcome to MacroEdTech Online Educational Services. We are running revision series for GATE 2025 Data Science and Artificial Intelligence. Initially, we are dealing with statistics for data science, and in today's short video, we will solve some questions related to Bernoulli distribution. So let's start. The Bernoulli distribution is one of the most fundamental concepts in probability theory and statistics. Its importance lies in its simplicity and wide application, especially in scenarios where there are only two possible outcomes, often referred to as a success and failure. You can see here Bernoulli trials. Many experiments are dichotomous in nature. For example, a tossed coin shows a head or tail. A manufactured item can be defective or non-defective. The response to a question might be yes or no. An egg has hatched or not hatched. The decision is yes or no. In such cases, it is customary to call one of the outcomes a success and other not success or called failure. For example, in tossing a coin, if occurrence of head is considered as a success, then occurrence of tail is failure. So when will be a random experiment are called Bernoulli trials. Please remember these conditions. First one, there should be a finite number of trials. Second, trials should be independent. Each trial has exactly two outcomes, success or failure. The probability of success remains the same in each trial. Let's understand with an example. Throwing a die 50 times is a case of 50 Bernoulli trials, in which each trial results in success, say an even number, or failure an odd number. And the probability of success is same for all 50 throws. Obviously, the successive throws of the die are independent experiments. If the die is fair and has 6 numbers 1 to 6 written on 6 faces, then probability of success will be 1 by 2, and similarly probability of failure is also 1 by 2, because P plus Q, probability of success and failure, equal to 1. Let's understand the Bernoulli trials with the help of one example. If a fair coin is tossed 10 times, find the probability of exactly 6 heads, at least 6 heads, at most 6 heads. So the repeated toss of coin are called Bernoulli trials. Let X denote the number of heads in an experiment of 10 trials. So X has a binomial distribution with n equal to 10, and probability of head is 1 by 2, and probability of tail or not head is also 1 by 2. So please remember, this is very important formula to solve questions related to Bernoulli trials. Probability is NCX, P to power X and Q to power N minus X. Now we will put X equal to 0, 1, 2 up to N according to our requirements. Now we will use formula. Here N equal to 10 and X equal to 6 for first case. So in first case, we are exactly 6 heads. So we'll put all values and ultimately we'll get 105 divided by 512. Now second case where at least 6 sets. So at least 6 we can write 6, 7, 8, 9 and 10. So we have all possibility 6, 7, 8, 9 or 10. So in each case we will put this equation and we'll get result. So you can see here after putting all values we will get result 193 divided by 512. And third case at most 6 sets. What do you understand by at most? Maximum 6. So possible ways 0, 1, 2, 3, 4, 5 and 6. So again we will put 0, 1, 2, 3, 4, 5, 6 in Bernoulli trials equation. So after putting all values we will get 53 divided by 64. Let's see one more example. 10 eggs are drawn successively with replacement from a lot containing 10% defective eggs. Find the probability that there is at least one defective egg. So please remember, to solve this kind of question, you can use at least one defective equal to 1 minus none of them defective. Or you can write now we'll solve this question. Let x denote the number of defective eggs in a 10 eggs drawn. Since the drawing is done with replacement, the trials are Bernoulli trials. So x has a binomial distribution with n equal to 10 and probability of defective eggs 10 divided by 100, 1 by 10 or 0.1. So q, because p plus q equal to 1, so q will be 0.9. So we have to find probability that there is at least one defective. So one defective equal to 1 minus none of them defective. So 1 minus 10, now x equal to 0 because none of them defective. So after solving, you will get this value. So this is our answer. So that's it for today. Thanks for watching. In upcoming days, we will solve some more questions related to statistics